Good morning, students. Today we are going to see the recap of Unit 1. So, in the first class, we have discussed about data analytics and machine learning and what is the importance of this course, why we need to study this course. Right. Since your exam, the FAT 1 exam is coming very soon on 20th and 21st. So I would like to recap the unit 1, what has been covered. So that would be helpful for you to understand and recap the things, what has been covered in the unit 1. So data analytics in chemical engineering involves the systematic analysis of data generated from chemical processes to optimize the efficiency, improve the product quality and enhance the safety. So for any chemical process, let us assume a reactor, CSTR, continuous state tank reactor. So the reactor, the purpose of reactor is to convert the reactant into product. So during this process, actually we may get a lot of information as data. We have a dependent variables as well as the independent variables. So the independent variables in a CSTR, let's say assume we have temperature, pressure, the concentration of the reactant. So the final product, that is the concentration of the product which has been formed, is considered to be a dependent variable. So the reactant concentration is a function of the temperature, pressure and concentration of the reactant. In that case, during this process, we may get a lot of data by the system. So we need to analyze the data generated from the chemical process to optimize the point, so that at particular point of dependent variable, at the particular point of independent variable, we may get a dependent factor very high, that is a response. So we should know the when we need to get a optimized point. So for which we need to analyze the data. So the data analytics will help you to do so. So it is an interdisciplinary approach, integrates mathematical modeling, statistics and machine learning with the core chemical engineering principles to make data driven decisions. Traditionally, chemical engineers relied on experimental data and theoretical models. So when you say the experimental model as well as the theoretical model, we have a non-empirical equation and empirical equation. So when you see, for example, Antonio equation, that is a non-empirical equation where the unit consistent will not be there. Okay, and also this has been arrived from the experimental data. So this type of modeling, whether is a what you called a empirical formula or non-empirical formula. I can give an example for these models. For example, as we know, as the altitude increases, the boiling point decreases. Boiling point of the substances decreases because at the higher altitude, the pressure is lower. That you know already. Let's say you have I want to boil a water at a ground level. So you know already the boiling takes place at 100 degrees Celsius. The same water, if you want to boil at a Ooty at a higher altitude, let's say you have 900 meters or 2000 meters high. Okay, when I say the altitude of that mountain is 200 meters and you are at the apex of the mountain where you want to boil the water. So water will boil at what temperature? Definitely will be at the lower temperature, because as per the definition of boiling point, the boiling point is the temperature at which the vapor pressure is equal to the atmospheric pressure. So at higher altitude the pressure will be very less. So in that case, what happens actually, even at 93 degrees Celsius of 2000 meters high from the ground sea level, obviously the water will evaporate at 93 degrees Celsius. So why I am saying this example, when you want to see the vapor pressure as well as the temperature, okay, the relationship, either you can go for Clausius-Clapeyron equation or else you can go for a Antonio equation. Okay, both are different. One is empirical, another one is non-empirical model. Okay, so what we need to know is that once you have process and you want to have a what is the difference between the empirical formula as well as non-empirical formula, that is the date model which has been arrived from the experimental data or from the theoretical models. So that's what I would like to highlight. Okay, but what with advancements in computing and data science, engineers can now analyze vast amount of data in real time to predict the outcomes and detect anomalies and enhance the process control. So in the last class, I mean in the unit 1, I already told you anomalies are referred to the data points or patterns that deviate significantly from the normal. So you maybe find some data may be skewed or some may be deviated from the line. Okay, so that type of data, that is called deviation from the data, that is called anomalies. So what analyze the vast amount of data in real time to predict the outcomes, which one, what are the data which are been need to be neglected, or what is the noise of that particular data, noise in the sense, okay, for example, I will tell you, I am taking the video audio, I mean the video along with the audio, right? So because you are the slides are projecting, right? So when you see, I just stop my fan because the noise may comes. Similarly, whenever you collect the data, some deviation will be there, so that has been considered as a noise, that data need to be removed. I hope you understood what I am trying to say. So and enhance the process control. So engineers can analyze the vast amount of data to predict the outcomes, detect anomalies and enhance the process control. So is here actually what for we are doing all this, because when you know the data, certain types of independent variables which has been varying when you have the model, and if you identify the output, okay, instantly, okay, we can take a proactive measures. Okay, that's the thing. So the main purpose of doing data analytics is to analyze the vast amount of data to predict the outcomes, detect anomalies and enhance the process control. So what is it, why we need to study this data analytics? One is for process optimization and the efficiency. Another one quality control and assurance. So this we are already elaborately explained in the unit 1. So I don't want to get into each and every lines. Just try to understand the concept. Okay, process optimization and efficiency. When we say is a process is optimized, so there may be a dependent, what you call it, independent variables. In a particular independent variables, the system is considered to be a optimized point. So obviously, when we say is a process optimized, we will get a higher yield or the cost reduction is low. That means the energy consumption is low. So then we consider is a process is optimized. Okay, so the process optimization and efficiency is a very important, that we need to fix at what data, that is a independent data, this has been achieved. So here they have given an example analyzing the real-time sensor data in a distillation column to optimize energy consumption and maximize the product quality. Coming to the next point, quality control and assurance. Using machine learning to predict the product defect in polymer manufacturing based on the historical data. So what is machine learning? So machine learning, we need to train this data and then use the testing the data. So how to do it? If we have a large quantity of data, okay, it's a big data. Just imagine we have a large quantity of data, already we have it. So we could able to predict the behavior of that particular data. How, what are the variables which has been changing? For example, pressure, temperature. If it changes, what is happening to my product concentration? Okay, so by correcting, knowing the data, when at different conditions, but different thing, the system will model. I mean, machine learning. That means what? Testing the data as well as the make them to understand how it behaves. Okay, that's a very important training. Training in the sense how it behaves. So, for example, anything. So, for example, if you go to the sports, the people will not test you immediately, right? They will train you actually what you need to do in order to be a best sportsman, right? So training is fun. Then next one, they will test you whether you could able to run as that of the fastest runner. Okay, so they will have a fixed point. So similarly, the training and testing is a part and parcel of machine learning. Okay, so the machine learning, how this system understand your thing. So that will help you to predict the product defect in polymer manufacturing based on the historical data. So this will help you to have a quality control. Okay, quality control as well as assurance. So if any deviation, so ensures consistency in production by detecting the deviation in product specifications. Coming to the next point, predictive maintenance. Okay, what do you mean by predictive maintenance? So prevent equipment failure by predicting when maintenance is needed. Okay, when maintenance is needed. So we have just predicting when it is required. Okay, prevent equipment failure by predicting when the maintenance is needed, and also environmental and safety compliance. So these are the ways the data analysis will help us to in terms of the chemical engineer perspective, environmental and safety compliance, because the reduces the emission is one of the most challenging work in the industry, because this is happened because of the unwanted product, or maybe by means of wanted product also there may be some unwanted byproduct may form that need to be cleaved off or that need to be reduced, okay, mitigated before it has been discharged to the environment. Okay, coming to the next point, cost reduction and resource management. So as I told you, when you optimize the point, okay, in all aspects, not only the material resources, but in all aspects like energy, okay, so obviously the cost will come down. Minimize the raw material usage and energy cost by optimizing the process parameters. And coming to the next point, decision making and risk management. So enables data driven decision, reducing the uncertainties in process of operation. So data driven decision, if we have a lot of data, we could be able to know when this data arises, there won't be any issue. If the, for example, if the pressure is 4 bar, okay, fine, the system could be able to withstand up to 7 bar. If the pressure is become 8 bar, what will happen? Obviously, there may be chances the material of the design would not be able to withstand the force which has been exerted by the pressure. Obviously, there may be chances of blast. If the external pressure is high, what will happen? There may be a chances of buckling effect. So when you have the data which is within our range, which is under control, obviously we don't have any issue. So whenever the data is away from the collected data, and obviously it has been taken out, I mean that need to be taken care for decision making. So that particular time, what are the what are the action which we need to take. So analyzing the past accident report in a refinery to implement the preventive safety measures. So during the accident, so you may have got some amount of data. So that data is considered to be a need to be under the what is called scanner, or what is called otherwise um, radar. So when this type of data arises, we should be very careful on that. Okay, so analyzing the past accident report in a refinery to implement the preventive safety measures. And next one is research and innovation. So we also can use this data analytics in research and innovation, and also AI based modeling refers to the application of artificial intelligence techniques such as machine learning and deep learning. So what do you mean by machine learning and deep learning? Deep learning, we have plenty of data. Okay, so deep learning will help you to understand the process more accurately. Okay, so deep learning to develop the predictive models for complex chemical engineering process. These models analyze historical and real-time data to optimize the operation, improve efficiency, enhance decision making. Coming to the conclusion of data analytics, data analytics is a revolutionary in chemical engineering by making processes smarter, safer, and more efficient. This already we have seen. So we will go to the what is data analytics. Okay, so we have defined the term. Okay, is a process of examining the raw data to extract the meaningful insights. In chemical engineering, data analytics is used to optimize the process, improve the product quality, enhance the safety, and reduce the operational cost. And what are the types of data analytics are there? Okay, one is descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analysis. So with this example which we have already have seen in the Unit 1, right? So what is machine learning? Machine learning is a subset of artificial intelligence that enables to computers to learn from the data and make prediction without being explicitly programmed. Okay, so the system will analyze. So when this variable changes, how the response is changing. So without you have giving a modeling equation, that the system itself from the data it will understand. Machine learning is a subset of artificial intelligence that enables computers to learn from the data and make prediction without being explicitly programmed. Explicitly programmed means with the model. Okay. Instead of using fixed rules, machine learning algorithm identify the patterns in data and improve their accuracy over time. So this is called machine learning. It's a subset of artificial intelligence that enables the computers to learn from the data. Okay, and make the prediction. What is deep learning? We are giving a lot of data over there. Okay, so under the types of machine learning, we have two types. One is supervised learning, and another one is unsupervised learning. So the model learns from the labeled data where input-output relationships are already known. That means the correlation is already been known. In unsupervised learning, the models find hidden pattern in unlabeled data. Okay, so there won't be any correlation. The model find hidden pattern in unlabeled data. So now, what is labeled data and unlabeled data? That also we have seen. Labeled data consists of input data that is paired with corresponding output labels. So that's what I told how it has been related with the dependent variable and the independent variable. Okay, so examples in chemical engineering we have already seen. For example, in a reactor, changing the pressure, temperature, the yield that is a reaction yield. Okay, so that is the output, that is a response. Okay, so uses machine learning, supervised learning uses label data to train the models. Okay, to train the models. There is some example in real life is spam detection, medical diagnosis. Okay, so in email, how the system is finding out that is a spam because it has been sent to for many people. Maybe that is one, and otherwise that email ID itself found to be a spam. Okay, so it will filter the data. What is unlabeled data? Input data without predefined output labels. There is no correlation has been given here. Unlabeled data consists of input data without predefined output labels. The model must find hidden patterns, and the relationship between the data without knowing the correct answers. That is very, very important. Unsupervised learning. So, what is used in machine learning? Okay. So, what are the labeled data? What is unlabeled data? So, output labels are available in labeled data, yes, whereas in unlabeled data, no. So which we have seen already very deeper, so I just skip that part. So what is a deep learning? Is a specialized branch of machine learning that uses artificial network with multiple layers to model and analyze the complex pattern. So we have seen the data analytics, now we are seeing the deep learning. So and also we have seen already the machine learning. So the deep learning is a specialized branch of machine learning. Okay, it's a branch of machine learning. So under the machine learning only this deep learning comes into picture, that uses of artificial neural network with multiple layers to model and analyze complex patterns in data. Okay, it mimics the way human brain process information, making it highly effective for tasks like image recognition, natural language processing, and predictive modeling. So machine learning, deep learning is a branch of machine learning that uses the artificial neural network. Okay, so artificial neural network, I will we have already seen actually in unit 1. Okay, I will recap all this part again back. Okay, so how deep learning works? So deep learning model consists of artificial neurons arranged in layer, input layer, hidden layer, and output layer. Okay, so this we have already seen. So what is the application of deep learning? Is used for process optimization, fault detection, predictive maintenance. Okay, predictive maintenance. So the next point is data exploration. Understanding the data exploration and visualization. Very, very important. What is data exploration? Okay, data exploration and visualization are fundamental steps in data analytics, allowing engineers and scientists to understand clean, and interpret the data effectively. So we need to explore the data and visualize the data, how it looks like, right? So importance in chemical engineering of data analytics helps in understanding the large data sets from chemical process, facilitate early detection of errors or inefficiencies in production. So data exploration involves analyzing the raw data through summary statistics, visual methods, and data processing techniques. So steps in the data exploration: data cleaning, descriptive statistics, data transformation, detecting outliers, and feature selection. So how to explore the data? Data cleaning. Okay, removing the missing values, that is very important. For example, noise or something. Descriptive statistics, find the mean, median, mode, standard deviation, and percentage. Data transformation, normalizing and encoding the data for future analysis. Detecting outliers, that means anomalies. Identifying the anomalies, that means deviation from the data, using visualization technique like box plot. Feature selection, identifying the most relevant variables for predictive analysis. So consider a data set that records temperature and pressure reading from a reactor. Before using the machine learning to predict the reaction yield, it is essential to clean the missing data, missing values, remove outliers, and standardizing the units. So what they say, before you use the machine learning, once you collect the data, try to identify the data, what are the values which are outliers, that means deviation from the data, okay, and essentially clean the missing values, okay, that need to be clean. Okay, so before using the machine learning, so data visualization, so the definition goes like this, so that we have seen already. Okay, so what are the different types of analysis? Univariate analysis, multivariate, bivariate analysis, and multivariate analysis are there. One variable, two variable at a time, three or more variables. Okay, so let's say univariate analysis, varying only a single variable. So bivariate means vary the two variable, and multivariate means vary the three variables. So correlation between the multiple variables using the color intensity. So bar chart, how it looks like, line graph, this we already have explained to you. What is scatter plot, what is histogram, this all you have studied, right? So Python libraries and all libraries are useful to for data visualization. So you may ask me whether can I do use actually the MATLAB? Okay, yes, we can do it, or else Excel, even the Excel can give you the chart, scattered graph or bar chart. Okay, so apart from that, the softwares which has been used are Python's libraries and R libraries. You can go for a this type of plot, that is matplot library, Seaborn, Plotly. In R libraries, you have ggplot and Shine. Okay, so coming to the application of this data visualization. Okay, monitoring the chemical process, reaction kinetics, industrial safety maintenance, and environmental assessment. Challenges in data exploration and visualization. What are the challenges in data exploration and visualization? Data quality issues, missing or inconsistent data, need for proper data processing. Okay, choosing the right visualization technique, that is also a challenge. Select appropriate charts for different data types. When we need to go for histogram, when we need to go for bar chart. Excuse me. Interpretation errors, misleading visualization due to improper scaling or labeling. That is also very important in challenges while collecting the data. I mean, data exploration and visualization. So now we move to the statistics, descriptive statistics play a crucial role in chemical engineering application where large data sets are collected from processes such as reaction kinetics, thermodynamics, heat and mass transfer, fluid dynamics, and process control. All are core subject of chemical engineering. Mass transfer, heat transfer, thermodynamics, process control, chemical reaction engineering. So descriptive statistics play an important role in chemical engineering application where large data sets are collected from the process of the core subjects of the thing. Okay, so from the process of different unit operation and unit processes. I can put it in a simple way: the unit operation and unit processes and the instrumentation along with the process control. Under the coming under the process control. Okay, so you know what is process P and LD diagram. Okay, so is when you try to put a flow chart, that is P and LD diagram, you need to implement what is the unit operation, unit process, how the raw material has been converted into product, what are the things which is required, what are pumps, what is the instrumentation which is required, all need to be put down, right? So this data sets, once you collect from this particular flow chart, okay, how we are going to study the parameters. What is the effect of the parameter data which has been collected? That we need to understand, right? So below are the complex examples demonstrating their use in real world chemical engineering scenarios. So what is mean? What is median? What is mode? I don't want to repeat this. Okay, standard deviation. I have given a lot of examples. Even a normal distribution in exam, the people will look for a deviation, standard deviation of around 12 marks. Okay, so, what is percentile? What is percentage? Percentage you know already. Percentile in GATE they will use to add. Okay, if your student test score is 90%, it means that 90% of the student score lower than them and 10% scored higher. Percentile ranking. So, application of process optimization. So, discrete statistics are critical in predictive maintenance and process optimization. Heat exchanger efficiency monitoring, process optimization. A paid heat exchanger records efficiency values over time. If the standard deviation is high, it suggests issues like fouling, scaling, and uneven heat distribution. Pressure fluctuation in a pipeline. Let's imagine the pressure fluctuation in a pipeline. If the pressure is fluctuated, what does it mean? There is a pressure drop, right? Pressure fluctuation. So obviously in a pipeline there is a pressure drop, so the flow will be less. A large range or variance in pipeline pressure may indicate the potential blockage or leak or compressor failure, because the compressor failure, it will compress the fluid, because we normally the pressure drop will occur, right? If the median pressure is significantly different from the mean, extreme pressure surges might exit, requiring the safety system recalibration. Okay, coming to the reaction kinetic analysis. So application under the reaction kinetic analytics, statistical measures help in determining the reaction rate consistency by analyzing the mean conversion rate and variation over multiple experimental runs. Okay, so this also we have seen environmental engineering application as well as the quality assurance. So descriptive statistics help chemical engineers in all the monitor and control the reaction kinetics, mass transfer, heat transfer. Okay, ensure quality control, improve efficiency and safety, and detect product process abnormalities yearly to prevent the shutdown or accidents. So before getting into the data mining revision, I stop it here. Hope you understood. The students understood the recap of thing. We'll see in next class.